We're here in Greensboro, North Carolina, where HondaJets are made, and I'm here to fly the HondaJet Elite. We're going to show you what makes the HondaJet Elite different from the original HondaJet, and also some of the features that set the HondaJet apart in the light jet market.
HondaJet Elite can fly 1,437 nautical miles with IFR reserves, and it can carry up to 8 occupants. One of the interesting features of the HondaJet is the over-the-wing mounted engines. This is a rarely used configuration in aviation and has never been used before with a business jet. The advantage of the over-the-wing mounted engines is that it opens up a lot of space in the rear of the fuselage, thus allowing room to include a full lavatory. A couple of the key changes are on the outside of the aircraft.
One of the new features on the Elite is this perforated inlet, where we drilled a large number of small holes in the barrel there, and they act as an acoustical device to cancel out some of the dominant frequencies of the engine, making for a significantly quieter cabin. We ended up extending the horizontal tail. The goal with that was to reduce our takeoff distance, which is now about 500 feet shorter than the baseline model. A side benefit as well is that that allows us to make the takeoff characteristics a bit more predictable, a bit smoother in the rotation with lighter forces. And it also allowed us to get rid of the vortex generators and the T-strips we had on the tail, reducing the drag of the airplane and giving us a bit more range.
The changes on the external airframe are subtle, and inside the flight deck, it's only when you start flying the Elite that you notice the new features. These include faster microprocessors and higher resolution in the Garmin G3000 displays. In the cabin, the Elite offers a new galley option with a coffee maker, ice bins, and lots of storage space. We're carrying 1,980 pounds of fuel today, about 1,000 pounds fewer than the maximum load. For today's flight, we are Honda Test 12. It took only 5 minutes to go from switching power on to finishing all the pre-flight checks, including the systems tests, which finished with the stick shaker. A new Elite feature is graphical weight and balance calculations in the avionics. The legacy HondaJet could only do load calculations, but not the balance. I plugged in the weight for the crew and one passenger plus a small amount of luggage. After syncing the fuel showed by the gauges, the MFD showed our weight and balance envelope and the changes due to our projected fuel burn. Flight planning is easy, especially for pilots who have learned to fly with Garmin avionics. Another new Elite feature is takeoff and landing data in the avionics, making performance calculations much simpler. Once I selected our takeoff configuration, for example, whether we needed icing equipment switched on, the system showed us our reference, or V speeds. These are about 5 knots slower than the legacy HondaJet thanks to the aerodynamic and weight improvements. This translates into less runway required for takeoff and landing, and also better safety margins. This also calculates second segment climb, wind components, and initial level off altitude, if applicable. Once I accepted these numbers, then the V speeds automatically post on the PFD's airspeed tape. Starting the 2050 shaft horsepower GE Honda HF120 turbofans is simple. Push the start button until the green circle lights up, then release the latch on the throttle and pull it up to idle, then just watch the gauges. The takeoff landing data checks to make sure the flaps setting matches what we selected during flight deck setup and flight planning. If they don't match, when advancing the throttles, we'd get a takeoff warning because of the misconfiguration. This is a helpful feature for a single pilot and something that is common on much larger airplanes. The new avionics hardware has faster processors, so when you zoom or pan the map, it's instantaneous.
Honda Test 12, runway 23 right, line up and wait. Honda Test 12, Greensboro Tower, fly runway heading, runway 23 right, cleared for takeoff.
We're cleared for takeoff and advance the throttles to maximum power, and the HF120 engines push us forward. It's subtle, but the nose feels a little lighter on rotation, thanks to the larger horizontal stabilizer, and once in the air, the pitch control feels a little crisper. With ADS-B in as part of the standard equipment, we can easily see other traffic on the MFD. Switching to the traffic page makes it even easier to see other traffic and their trajectories. Climbing through 17,000 feet to flight level 230, I finally put the autopilot on. The HondaJet handles so well, I'm reluctant to use the autopilot. NEXRAD data is now animated, so you can get a better idea of how storms are developing. During the climb, we detected some ice accumulation, so the anti-icing for the wings and tail inlets switched on automatically. We're cleared to climb to flight level 310, where we'll do a performance check. Stefan showed me how easy it is to pull up the environmental controls and set flight deck and cabin temperature. After turning off the engine inlet anti-ice, climb rate increased to about 2,000 feet per minute from 1,200. The fuel system synoptic shows the new fuel capacity of the Elite. The center tank is regulated to keep it not quite full, supplied first by the fuselage fuel tank. We're burning just over 500 pounds per hour per engine during the climb. We pulled up the dedicated weather page to see the additional weather information we could have. On the MFD map, there are only certain weather overlays that we can view. Another new feature is the progress page inlay. Stefan says that this is handy when flying outside the US, where there are more mandatory position reporting points. This is a lot like an FMS progress page, and it's something new for Garmin avionics. A new feature for the Electronic Stability and Protection, or ESP, is the pitch ladder on the PFD, which shows you the pitch attitude that would result in stick shaker. This makes it easy to tell when speed is getting too low, and pilots can use this for wind shear avoidance to extract maximum performance while flying right at stick shaker speed. If you slow down too far though, the ESP will nudge the controls to remind the pilot to push forward and speed up. It's ISA plus 7 degrees at flight level 310, and we're cruising at 414 knots at maximum continuous thrust and burning 500 pounds per hour per engine. If we were at the maximum altitude of flight level 430, we'd burn nearly 600 pounds per hour for both engines at high-speed cruise, or 550 pounds per hour for both engines at long-range cruise. The handy cruise speed control adjusts N1 speed to maintain a set airspeed, a convenient feature for a jet without auto throttles. The cruise speed control is helpful in the terminal area, for example, where we could slow to say 170 knots, then set the speed control to hold that. Moving the thrust levers turns the speed control off. I turned off the autopilot and flew some banks to feel the handling at altitude. The controls feel a little heavier at high-speed cruise, which is to be expected. After receiving the ATIS for Greensboro, we preset the altimeter setting so it's ready to switch when we descend below flight level 180. We're cleared to 11,000 feet at Trax intersection, so we set a VNAV to there. When we captured the vertical path, I just had to pull the power back to keep from overspeeding on descent. We calculated the landing speeds. We had already plugged in the arrival to runway 23 right, then we loaded the Sirius XM weather, and it gave us the VREF, landing distance, etc. I set up the visual approach to 23 right. It's just another procedure at the bottom of the list after the regular approaches. We set it up with vectors. It's a 3-degree glide path, but it doesn't consider if there is terrain. The air traffic controller gave us a block from 8,500 to 10,500 feet for some air work. With the autopilot on, I descended to 9,500 feet and pulled the power to idle to demonstrate low-speed protection. this is like the classic situation where a distracted pilot forgets to add power after leveling off. First, we got visual and aural alerts. Then ESP lowered the nose to avoid stalling. To recover, I advanced power to max continuous thrust. ESP will roll the wings level 2 if we were in a turn. With the power at idle, I can see the stick shaker speed on the speed tape and the angle of attack climbing. The aural warning said airspeed, and then the nose pushed down at just a few knots above stick shaker speed. We were descending at about 1,200 feet per minute. After adding power to max continuous, then the airplane automatically goes back to the selected altitude because the autopilot is still on. I disconnected the autopilot for some steep turns at 200 knots. Turning to the left first, I could feel the ESP nudge at 45 degrees of bank. I could easily fly through the nudge. You can disable ESP if you want, but it defaults back on when starting up. Then I pulled back to feel the stick shaker and the underspeed protection mode. On the PFD, I could see the pitch attitude coincide with the stick shaker feathers. The aural warning called out airspeed, airspeed, and the shaker shook. Then I could feel the ESP nudge. We then did a rudder bias demo. Stefan cut power on one engine, and it's really a non-event. The rudder bias looks at the calculated thrust difference between two engines and your airspeed and applies force based on a predefined schedule. It's not really apparent during this demo that the engines are mounted on the wings instead of the aft fuselage. Returning to Greensboro, we activated vectors to final for the visual approach, which paints an extended center line for the selected runway. Even though this isn't an IFR approach, I could fly it like an RNAV approach and even use the autopilot in approach mode. The HondaJet can fly steep approaches up to 6.65 degrees. I flew just above a VREF speed of 108 knots to runway 23 right. The landing data showed we needed only 3,162 feet of the 9,000-foot runway for actual landing distance. Our landing weight was about 8,900 pounds. The HondaJet felt comfortable and the controls harmonious at the slow speed. Just a small amount of nose up as we neared the runway was enough to set us up for a smooth touchdown. And I applied the improved brakes, which are very smooth, to turn off at the next intersection.
If you've enjoyed this video, please give it a thumbs up, share it, and subscribe to our channel. Also, visit ainonline.com and check out our e-newsletters for all the latest on the aviation industry.